Hey guys, welcome to day 15 of 15 days to Spring Boot Mastery Challenge. Today is our final day. In today's video, let us learn to Dockerize our Spring Boot application. If you have bumped into this video directly without watching the previous videos, no worries. You can very well understand this because we will be doing this application from the scratch. Guys, I hope you had a great learning in Spring Boot. Today is our final day. So let us have the finishing touch. Let us get started. Okay, guys, now let us see how to Dockerize our Spring Boot application. These are the steps that we need to follow to Dockerize our Spring Boot application. For this, first we need a solid Spring REST API. Let us build our Spring REST API before following the steps. Let me open Spring Toolsuit. Let us create a Spring Starter project. File, New, Spring Starter project. Let us have the application name. Type is Maven, packaging is jar, Java version is 21. This is a simple Spring REST API. So let us have the group ID as com.greetapp.dast and package as com.greetapp. Click next. Our application is not integrated with the database, so we don't need any database specific dependencies. We need only web as dependency because this is a REST API. Click finish. Now let me open the application. First, let us create a controller. Select the package, right click, new class. Let me have the package name as controllers. Class name is greet controller. Let us annotate this class with @REST-controller. Now let us add two methods with the appropriate URL pattern. Let me have the first method as public string greet message. Let me pass the parameter as username. Return grade day plus username. Let me annotate it using @getMapping. Pass the URL pattern /greet/username and add @path variable annotation. Let me add the next method also. Public list of string show books. Return. Either you can use arrays.asList or you can use list.off. Let me pass few book names. Annotate it with @getMapping and pass the URL. The URL here is show-books. Now our controller is ready. Before Dockerizing our application, first let us run this application and check whether it is working properly. So select your application, right click, run as Spring Boot app. Let me maximize the console. The application is up and running. It is running in port number 8080. Let us check both the URLs. Let me open the browser. Localhost :8080/greet/Priya. I have got the first output. The next one is show-books. So we have got the second output also. Now let us follow the steps one by one. The first step is to create a jar file. That is, we are going to package our application. We need to package and generate a jar file. Let me open Spring Toolsuit. Now, to package this application into a jar file, use the command mvn package. If you are using IntelliJ, you can explicitly go and give it as mvn space package. Now we are working with Spring Toolsuit. So I will use the GUI to provide the command. Select your application, right click, run as Maven build. A new window will open like this. Here, give the goal as package. Now guys, when you give package, Maven will run the goal step by step. First it will clean, then it will compile, then it will do the testing, then it has to do the packaging. Sometimes in case of testing, it may throw an error. To avoid that, you can select skip test. So in this case, the testing part will be avoided and it will generate the jar file. Let me click apply. So check the goals here. It is package and you have to select skip test. Click run. I am in the console. As I told, first it will clean, then compile. It has to do the process of testing. We have given skip test. So the tests are skipped. Finally, it is building the jar file. Okay. Let us see the location of the jar file. Let me scroll it to the right. In my application, the folder name is target. Within target folder, we will have the jar file. Select the target folder. The target folder is empty. You need to refresh it. Select the folder, right click, refresh. Open target. Inside that we are having the jar file. Okay. Now this jar file name is too big. We can rename it and have a simple file name also. So let me rename it function F2. spring-boot.jar. Click OK. Now the jar file is ready. Guys, there are two jar files. You need to select the first one and rename it. Now the first step is ready. Let us move on to the next step. I have done the second step also, that is renaming the jar file. Actually it is optional, but the jar file is too big. There are scenarios where you may make typos. To avoid that, I have renamed the jar file. The next step is we need to create a Docker file in the root directory. The file name should be Dockerfile. D capital, F lowercase only. No extension. So let me go back to Spring Tool Suite. Select your project, that is the root directory. Before selecting, be very careful and check whether you are selecting the correct project. Now select the project, right click, new file. The file name should be Dockerfile. What is the purpose of this Docker file? This Docker file is going to have the configuration details relevant to your application. In our case, this application is a REST API. So we need to specify the port number in which it is running and what is the name of the jar file. This application is dependent on the technology Java. So you need to provide the Java version. What about Spring? In case of Spring, all the dependencies are pulled from Maven during runtime. So that is not an issue. Okay. Now, how will I know what should be written in Dockerfile? You cannot always remember the contents of Dockerfile, but you should know how to take the commands and modify it. Let me show it to you. Let me open the browser. Now just type spring docker. You will get the documentation of spring.io. Click on the first search result, Spring Boot with Docker. Scroll down. Here you can see the Docker file. See the name of the Docker file, first letter is capital. Why I am insisting on this means, if you are making a typo, your application will not build the image. Now I need to copy this. Let me click on copy. Come back to the application and you can add it over here. This is expecting a Java version. Actually, we are not working with JDK 8. We are working with the latest version, that is 21. So how to identify this particular version? You cannot directly jump and write JDK 21. You have to go to Docker Hub. Docker Hub is a repository which is having images for different technologies, frameworks and libraries. Now let me open Docker Hub. Don't think that we are learning a lot or we are going back and forth to do each and every process. If you are copy pasting and if you are trying to do the application as such, then there is no learning. You have to understand from where to take what, from where to copy what. Only then the flow will be clear. Now let me open Docker Hub. Click on Docker Hub. Now I want to search for an image. Let me search for OpenJDK:21. Enter. So here we have the OpenJDK image. Let me click on this. So these are the recent images. Let me scroll down. Whatever is coming after colon is the tag name. I am looking for 21. Here if you notice, it is having only the latest versions. What I need is OpenJDK:21. So what we can do is, let us do one other search. Let me open another tab. Search for OpenJDK:21 Docker image. The moment I gave the search, automatically I am getting an image. OpenJDK:21-JDK. Let me click on this. OpenJDK. This is the image. So let me copy this. Now go to Spring Tool Suite. Instead of OpenJDK 8, we will be using OpenJDK:21-JDK. Okay, I don't need the next line. We need to provide the port number in which we want to expose. So expose port 8080. Guys, remember, already we ran the application. The application is still up and running. If that is the scenario, you need to close the console. Here. Now the console what we are seeing is the Maven console. That is terminated. Go here on the top, click on this arrow. Here you can see the other console, Spring Boot Docker. It is still running. So select that and terminate. Remember, your application should not be running. The port number should be free. Now I will go back to Dockerfile. The application is exposed in port number 8080. Okay. Now the third one is copy. Let me click on copy. Copy is a command which takes two parameters. It expects the source jar file name and the destination jar file name. See here, they have given examples also. In our case, the source jar file is inside target folder /target/file name. We have changed the file name. The file name is spring-boot. And now we need to give a destination file name. The destination file name is the file which will be identified by Docker. You can give the same file name or a different file name. Let me give a different file name, spring-rest.jar. You can give it as rest-api.jar, greet-rest.jar, greet-api.jar, or the same file name, spring-boot.jar. Everything will work perfectly fine. The next one talks about the entry point. When you are trying to run the application from Docker, it is expecting a command. How do you run your Spring REST API? You all know, select your application, right click, run as Spring Boot app. But in a real-time scenario, they run this application from the command line. In that case, you need a solid jar file. Run the jar file as java -jar space the jar file name spring-rest.jar. Guys, remember we tried to run lombok.jar earlier. The moment you double click on lombok, it means java -jar space lombok.jar. Similarly, here also we need to provide the entry point. See the entry point that is already given over here, java -jar space the file name, that is the jar file name, spring-rest.jar. Now our Docker file is ready. You might be wondering, we have added the Docker file after creating the jar file. Is it mandatory that first you need to create the Docker file and package the application? Not required at all. This Docker file is what we are going to run now to build an image for our application. Now let me save this. Let us see the next step. We are going to build the image. What is the command? Docker build -t. -t is the tag name followed by the image name that you want to give for your application. So what can be the image name? Guys, you can give any name you want. Simply you can give greet-API or spring-API, REST API. Whatever name you want, you can provide it. Followed by dot. What is the meaning of this? Dot represents the current directory. So you need to run this command from the root directory of your project. Your Docker file is available in the root directory only. So directly it will run the application. Now if you notice, I have given an example. I am giving a different image name. What is the purpose of this? Guys, in Docker Hub, I have created an account. My account username is S. Priyamathan, inside which I have created a repository. This is the repository name, colon, followed by some name. What is this? This is the tag name. I hope you can understand. The purpose of following this naming convention is when you are pushing your image to Docker Hub, that is, if you want others to use your image, you need to push your image to Docker Hub. During that time, you have to follow a proper convention. If the convention is available, it will be easier for you. Already I have opened Docker Hub. Let me show you my repository. Let me sign in. I have logged in. As I told, my username is S. Priyamathan. And you can see that /Junebatch, /Docker repo, /Spring repo. What are they? They are repository names. Colon, whatever you have got is your image name or the tag name. Let me click on one particular repository. Here you can see the tag name is greet API. So how exactly it will look like? See here, the image name is my username / the repository name colon the tag name. The tag name is nothing but the name that I am giving after colon. In our case, we have used OpenJDK. OpenJDK colon 21-JDK. This means this is the repository name and this is the tag name. Similarly, when you are building an image, if you want to follow this naming convention, it is better because when you are pushing it, it will be easier for you to push it to the repository. Because when you are checking the images later on, it will specify what is the repository name, what is the tag name and what is the username. In my case, this is the repository name. Technically, this is the username and this is the repository name. Okay. Now we will be doing this. Let me go to Spring Toolsuite. Okay. I want to open this application in the command prompt to build the image. So select your project, right click, show in System Explorer. Double click on this particular project. Keep the cursor here. Type CMD. Now let me increase the font size. Okay. We are going to play around with Docker. For this, first you have to start your Docker engine. Let me go to the search box. Type Docker. Select open. Guys, this is my Docker desktop. I have removed all the images and the containers that I had earlier. Your Docker desktop also should look similar to this. This is the images window. Let me click on containers. This is the containers window. The moment you build an image for a particular application, it will be shown in the images window. Using the GUI itself, you can create a container, but we will be writing the command to create a container for our REST API image. Guys, understand that image is like a Java class. For one Java class, you can create multiple objects, that is multiple instances. Similar to that, you can create one image for our REST API. From that image, you can create multiple containers. This means containers are like instances of a class. I am just showing an analogy so that you can understand. One single image, you can create any number of containers. Okay. Now, the Docker desktop is up and running. Let me open command prompt. The first command I want to type is Docker images. There are no images as of now. My dear guys, I already told you it will expect a repository name, a tag name, image ID when it was created and the size. Guys, if you are following my naming convention, then you will get the tag name as your application name, as in greet-API or REST API or book API or so on. If you are following some other naming convention without using colon, then Docker will provide the tag name as latest. I will show you both. Okay. What is the command to build the image? Docker build -t spriya-madan /master repo tag name greet API space. Now you need to provide the location of Dockerfile. Dockerfile is available in the root directory of our project. We are also in the root directory, so I can simply give dot. Enter. Now this Docker will read the Dockerfile line by line. First it has to download OpenJDK, then it has to check for the port number, then create the jar file based on the name that you have given and finish the process. You can see here the image name is spriya-madan /master repo greet API. Let us check it out. Again we will give the same command Docker images. See, this is the repository name. When you are pushing it to Docker Hub, this will be far better and easier. That is the reason I am giving this kind of names for my image. Suppose say, if I am giving a simple name as REST API, this will be the repository name. What about the tag name? It will be latest. Let me press enter. Let me just type Docker images. See here, the repository name is REST API, the tag name is latest. Here it is fine, but if you are trying to push it to the repository, during that time there may be a conflict. Okay, now let us check the Docker desktop also. Now both the images are created, right? If I want to create a container for this particular image, I can just go and click over here. When I click run, automatically a container will be created for this particular image. Guys, the name of the container will be given by this Docker itself. But I want to give my own container name. So let us do it by using the command. So this is the final step. Here we need to provide the name for our container also. Let me open command prompt. Docker run _name greet container -d. -d means detached. If you don't use this -d, the application will run in the same console itself. If you want to run the application in the backend, you can use -d. Next is -p. That is for port number. What is the port number that is exposed for running the application in Docker? I can just combine this together as -dp space. This is host port number : container port number. The first one refers to the host port number. The second one refers to the container port number. This means the application is running in port number 8080 within the container. If I want to access the application outside the container, the port number that I need to use is 8082. Space. I need to provide the image name or the image ID. Image ID is easier. So double click on this, copy and paste it here. enter. Now the container is created. To check all the running containers, the command is docker space ps. This will list all the running containers. This is the details about the container. This is the container ID, whatever you are seeing over here, the corresponding image ID, the command that is used for running our application. As I told you, to run a jar file, we need to use the command as java space -jar space the jar file name. Docker has used this particular command to run our REST API. Okay. And this is the container port number. This is the host port number. Fine. Now what next? This means our application is up and running within the container in port 8080 and it is exposed in 8082. So we can directly check our application. Before that, let us see in Docker desktop also. Let me minimize this. Go to containers. Here you can see the container. The port that is exposed is 8082. You can directly run from here also. Localhost :8082. Let me click on this. 8082/greet/priya. Enter. Here we have got the output. Show -books. Now your application is working perfectly fine. Let me go back to Docker desktop. See the name of the container, it is greetcon, because explicitly we gave the name for our container using !name flag. Let me go back to images. Again, let me click on run. It is asking for optional settings. I need to provide the host port number. Let me give the host port number as 8081. I am not going to provide any container name. Let me click run. The container is created and the application is up and running. You can see the log. It is running in port number 8081. Let me go back here. See the name of the container. Docker has given its own name. In this case, the application is running in port number 8081 outside the container. In this case, it is running in port number 8082 outside the container. Okay. So, we are having two containers for the same image. That's what I told you. Images are like classes. Containers are like instances of these classes. So, here containers are instances of one image. So, we have completed all these steps. Now, our application is successfully Dockerized. What next? I want to push the image to the Docker Hub repository so that others can use my image. For that, we need to do two steps. First is we need to create a tag for our image. The next step is we need to push our image to the Docker Hub repository. So, let us do that. The first command is docker tag. Let me give the command docker space tag. Let me press enter. It is expecting the source image name and the target image together with the tag name. Let me just give docker images. Let me give docker images. Now, let me add the command docker tag. The source image name is the repository name : greet API space. Let me check my repository over there. Let me select one of the repository. Let me select this Docker repo. I'll copy this repository name. Guys, you can simply give a tag name directly, but it will come with a weird name. So, to avoid that, just like how they have given the naming convention, target image : tag name. So, my target image is my username / repo name : tag name. Maybe I can have it as REST API. Enter. Now the tag is created. What next? I need to push. For pushing, this is the command. I'll copy this. The tag name that we have given is REST API. Enter. Now my image which is given a different name REST API is pushed to the repository. So here it is saying authorization failed. So let me give a Docker login. Login succeeded. Now again let me push. So I have logged in using my username and password. Let me try to push it again. Now the image is pushed successfully. Let us check it out in the repository. The repository is Docker repo. Full. Now here you can see the image that we pushed just now. Okay. What if you guys want to access my image? You have to do only one single step. You need to pull the image. Let me click on this tag. See guys, as I told you, see the image name. The username followed by the repository name colon the tag name. This is the image name. Okay. Let me show you the command to pull the image. Click on tags. Okay, this is our image. Copy this command. Let me come back here. Let me add the command. Now I want to pull my own image from the repository. See, we have done these two steps. We have created a tag and we have pushed the image to the Docker repository. Now from the same repository, I am trying to pull my own image. It is possible. What you guys are going to do is, you need to open Docker Hub. You have to search for my image. How? You can search for spriyamathan / you can get the repository name. From the repository name, identify the image. Then use the command to pull the image. Now in the command prompt, I have given the same command. Now from my repository only, I am pulling my own image. Now the image is pulled to my system. Let me check it out. The command is docker images. Enter. Now you can see the image that is pulled from Docker Hub. Okay. How will you create a container for this? Docker space run _name rest demo space -dp. You need to provide a port number 8085:8080. That is, this is the host port number. 8085 is the host port number. Space the image name. Because both the images are similar, you are having the same image ID. Now I will copy the image name :REST API. Enter. Now the container is created. Let us check the container docker ps. Here you can see the container. What we have created just now, REST demo. How to run it? Directly you can go to the browser. Here it is localhost :8085. Now it is working. /greet/Shri. That also is working fine. So what you guys can do, if you want to check my image, go to Docker Hub, search for my username together with the repository, get the proper tag. This time we tried with REST API, so you can pull that image and run in your system. Guys, I hope this is clear. We have learned how to Dockerize our Spring REST API. But remember, this is not enough. There are much more advanced concepts in this. Suppose say you have developed a Spring Boot application which is integrated with the database. The process is completely different. You have to create a separate docker-compose.yaml file. You need to provide the details, that is the configuration details or the service details relevant to whatever services you are having. What is the database that you are working with, the username, password, all the relevant details of this particular application. Only then you can start working with Docker. Now those are all advanced concepts and which is very intense. Now we have successfully completed our challenge. What next? Is this enough to become a Spring Boot developer? This is enough if you are a fresher, if you have just started your journey learning Spring Boot. But if you are a person who is working in a corporate, or if you are having certain years of experience, it is mandatory that you have to move on to the advanced concepts. As in, while integrating your application with the database, there are many challenges. You need to know how to work with associations, that is one to one, one to many mappings. You should know how to do projections. After you have created a REST API, you should know how to handle exceptions in a REST API, how to use response entity, how to generate a documentation for your application. And also, while working with authentication, I told there are few advanced concepts that you need to learn. That is how to authenticate using data-jpa, how to use JWT, OAuth and so on. Similarly, in case of containerizing your application, you need to learn few advanced concepts, that is using networking, using Docker Compose YAML file. So if you are using that YAML file, you don't have to do all the steps that we have been doing till now. It is enough that you run one single YAML file. But still, I can assure you that you have taken the first step and you have crossed a bigger milestone in learning Spring Boot. All these topics, whatever I have discussed, that is the advanced topics, that is available as a course in my portal. You can go to my portal, check on the topics and then decide what is your next step. I enjoyed this journey with you. I hope you all enjoyed too. Share your feedback in the comments. Thank you so much for joining in this journey. Let us learn, code and grow together. Thank you.